As far as see, the material is given, and more out of the 25 students, around 22 or 23 students they have taken. For example, brass 70% and CU and 30% is certain means most of them they are able to take the values. I was quite happy with that. Uh, that is that. Is that one? Heat and master and data book. All of you have taken it, right? Because I have corrected around 20 papers, 20, 25 papers, and most of them they have taken the values. Uh, it doesn't need for me to just show all the values. Am I correct, students?
Yes, sir, we can understand.
Yeah,
Yes, sir.
yeah. Especially, let me take one example. That is a brass. Okay, 70% is Cu and 30% is certain. So brass means 70% is Cu and 30%. So you can see here the density is 8522. Alpha value is 34.12 and specific capacity is 385 and thermal conductivity is 110.7. Okay. Similarly, the other material, okay, given in the problem is carbon steel AISI 1010. So carbon steel AISI. So you can see here at the bottom of the screen 7832. All of you are able to see this.
Yes, sir.
Is it
Yes,
visible
sir.
to you all?
Yes, sir.
Yeah, 7832 and alpha value and similarly C value, that is specific capacity joule per kg Kelvin, and some of them they have some in some of the cases they have substituted wrongly, and some of the students, one or two students, they didn't substitute the conversion of cm to meter. They didn't do it properly, ma. One student, I don't want to see, I don't know who is the student is. One student, he has mentioned that is 1.5 centimeter dia, so radius is uh, that is 0.75. Okay, instead of it he has put a 7.5 and he has proceeded the problem like that. So these small errors, I know that within 1 hour, it's very difficult for you to take the values. Okay, so that's why I have given everything, right? So from the data book, you can see and you can write it. Okay, but still, some of the students, I'm sorry, you have taken the readings, but your substitution and your calculations, it's I have to feel sorry for you people operating your calculators. Even that particular thing you have not done it properly. I don't know, see, this is what, see, when I do the problem, when I solve the problem inside the classroom, you are supposed to solve it along with me, but you people, you are not doing it. Am I correct or not? That's why, that's where all these mistakes will come. So even in the third problem, when you take the, sorry, first problem, pure aluminum, and again you can go to aluminum pure. That is the very first. Okay, so the first question, third year question, very first value is aluminum. So no need. Page number 2, first value, density, thermal diffusivity is given, specific capacity is given, and thermal conductivity is given. Uh, all of you students, most of you you did it correctly, right? As far as taking the values is concerned, students.
Yes, sir.
I mean,
It was easy,
Yes,
sir.
sir.
I think most of you have done it well, and especially I don't find anyone almost most of them that especially the composite wall problem 2A and 2B, most of them they have done it correctly. Most of them around out of the 25, around 17 or 18, 75% or 80% students they did it properly, and the third steel tube problem only some of them they didn't do well, but it's so simple again. And one more thing, students, I have given only 8 marks for those who didn't find 7 or 8 marks, depending upon the your accuracy of the value, heat transfer value. Because in all the questions, the interface temperatures were asked. Okay, so in question number 2, question number 3, as well as question number 1, And some of the students, even you can find here, find the heat transfer per unit area and interface temperatures. And some of them, they didn't find the interface temperatures. Why it is so, Mark? Why? I'm asking you a common question. Okay, anyone can answer. What's the problem? Because some of you might have experienced it. You might have not done it. That's what I said. Out of the 25 corrected, okay, around 10 students or 10 or 12 students, 50% of the students, they didn't find the interface temperature. Why? What is the reason? You neglected it, or what is the reason? Due to lack of time, or more calculations were the, what happened here actually? Students, I'm talking to you. Anyone can come up. Why all of you are keeping quiet here? Am I audible or not?
Yes, sir, you are audible, sir.
Yes, sir. What happened? Why most of you didn't find the interface temperatures? What's the reason? See, you know that. Who are all? Yeah, somebody try to ask something. Say something.
Time was the problem, sir.
Time. What Daya Karthik? Time is not there. See, these problems, we solved it in the classroom. I have given you assignment, and especially I didn't ask infinite solid. Actually, am I correct? All the three were lumped parameter only. All the three were Biot number less than 0.1. And in the last problem also, I have given 8.5, 8 or 9 to the students depending upon they have answered. Significance of dimensionless numbers. Actually, there are two numbers. One is Biot number and the other one is Fourier number. Most of them, they have written about Biot number. Some of them, they have written less than 0.1, greater than 0.1. And if it tends to infinity, it can be classified as a lumped parameter system or semi-infinite solid or infinite solid, whatever. Okay. What about the Fourier number? There is one more number, Fourier number. Am I correct? None of them. None of them they didn't. And the significance, it's not only saying about Biot number less than 1.1, greater than 0.1. See, this particular thing, most of them, they didn't do it. Biot number, it is nothing but the ratio. It's there in the screen. Internal conductive resistance to external conductive resistance or convective resistance. Most of them, they didn't write. No one out of the 25, that is especially around 7 or 8 members, they have got this question. No one has written this. What is Biot number? And similarly, see, here itself, it was given. I told you in the class, is the product of, not here, BA into F4. That is one. Yeah. You can see here, I think on the right hand side of the screen, all of you are able to see this? All of you are able to see this?
Yes, sir.
What it is mentioned, it is the product of Biot number and Biot number and what F4
Fourier
stands
number,
for?
sir.
Huh?
Fourier number.
Fourier number. Okay. So when I ask you the question of what is the significance of the dimensionless numbers, only Biot number you have written. What about the Fourier number? See, as a students, see, these are all the things where you people, you are doing mistakes. Yeah, finally coming to the first one. Okay. Now, the second one is very simple. The diagram was also given. Only thing is the solar radiation. Okay, heat radiated is equal to heat conducted plus heat convected. Okay, so what happens is the solar radiation. Okay, so usually we know that the radiative heat transfer occurs when there is a source which will be at a very high temperature and there is a receiving body which will be at a lesser temperature, and Q equal to sigma A T power 4 or sigma into shape factor into area into temperature difference between the two bodies. Okay, T power 4 minus Ts power 4. Most of you didn't write it. What is temperature? What is Ts? And here also you can see here, one is the collector plate, and 2 is nothing but the insulation, right? And 3 is nothing but the glass cover plates. 4 is nothing but the gap between plates, either air or vacuum. Okay. Now, what happens here is the purpose is you have Q radiated, which is equal to Q conducted plus Q convected. Right. So you will be having partial conduction as well as convection. Okay. And similarly here also, the very first question, and some of them, they are quite smart enough. I didn't took semi-infinite solid, and immediately I don't know, some of them they might have referred Sachdeva textbook or some other textbook. Imagine a highway road on a hot summer day. There is a problem, water splitting problem, or usually what happens is on a hot summer day, all of a sudden there is a rainfall, and what happens is immediately the surface is cooled. Okay, the top surface is cooled, but at a certain depth, it will not be cooled. Okay, they have written like that. So I didn't talked about, or I didn't teach you the semi-infinite solid technique, and that too also they didn't write it well. Actually, again, this is a on a hot summer day, means again uh, the identify the heat transfer process, and perform an energy balance. Okay, now again on a hot summer day, the heating surface, right, or the road surface may be you will be having certain thickness, right, and it will be, the temperature will be higher. Okay, so the temperature, the why high temperature, high surface temperature of the road is there. See, this is an open-end question. Okay, you can include radiation, or you cannot include radiation also, right? If you don't include radiation, then what happens is Q conducted is equal to Q convected. Okay, Q conducted is nothing but the heat conducted from the surface, okay, to the bottom of the surface and to the soil, and heat convected is nothing but from the surface to the air which comes in contact. Q convected is equal to HA del T, and Q conducted is equal to minus Ka dt by dx, or del T by del x. So Q conducted is equal to Q convected, and some of them, if you are able to understand the radiation process also, and if you want to include that, okay, as I mentioned earlier, it's an open-ended question. Okay, Q radiated is equal to Q conducted plus Q convected. So you are expected to think and answer. And similarly, the third one is, it's a purely annealing process, and so many times when I handled lumped parameter system, I told you this. Okay, heat treatment process comes as usually assumed as lumped parameter systems, right? What happens is, the air in the furnace is at 600 degrees, while the surrounding surfaces of the furnace are at 700 degrees. Okay, so the air gets heat from the surface. Okay, and surface, within the surface you will be having conduction, and air heat is transferred by means of convection, and from air to the stainless steel sheet which passes inside, it may be, the stainless sheet may be assumed as a lumped system. Okay, which may be at a room temperature, all of a sudden it is exposed to 600 degrees C. So again, you can use the Q convected. See, whatever which we have studied here, HA del T dt, which is equal to MCP dt. And similarly, yeah, this is nothing but the heat transfer into the body during time dt is equal to increase in the energy. And similarly, there is also one more thing here, which is mentioned here. Q suffix T, which is equal to HA into TT minus temperature at time T minus T infinity, which is nothing but the surrounding fluid temperature. So these are all the things which were expected from you, and you people, you didn't do it properly. And even in CAT 2, what about CAT 2? Whether it is going to be open book examination or closed book examination? And I think this Saturday is also a working day for you, instructional day for you. Am I correct?
Yes,
Yes.
sir.
Yeah. Which timetable it is? Coming Saturday?
Fridays.
Monday?
Friday,
Huh?
sir. Friday.
Friday. We don't have the class, huh? Okay. 1 minute. So you people, you didn't answer it. Okay, so these are all the things which I wanted to express to you. Okay, and yeah, anything you want to ask from me, you can ask now. Yes. Anything you want to ask?
Sir, can you just show the second question, sir?
Yeah. Yes. Go ahead.
No, sir. Question number 2, sir.
Two. Okay. Actually, there are three questions. You know that. Yeah. Yes, ma.
Yes, sir. I just want to check the question, sir. Like subdivision B.
B.
Yes, sir.
120 mm and 300 mm, 120 mm, 170 mm, and the thermal conductivity of the middle layer is asked, and the answer is around 1.34. Even some of them they got 1.31, 1.32 also. I have given those who have got 1.3. I have given full marks. That is, if they have found out the interface temperature, so also I have given 10 out of 10. Yeah, what is the thing you have in this? It's
No, sir.
very simple. It's very simple, ma. Actually, what happens is actually one of the student. Actually, I was surprised, and actually he has done it beautifully. What he did is Q equal to HA del T, and he has found out H value. He has taken H value, which is mentioned here as convective heat transfer coefficient as 8.5. Sorry, what is the inner convective heat transfer? One convective heat transfer coefficient 25. 25 into area, okay, per unit area into del T. So he used that is 25 into 1300 minus 1175, and he has got Q. Actually, that is only one guy out of the 8 or 9 papers I have corrected. Only one guy did it, and I was so happy because I didn't use it inside my classroom. Okay, I follow the steps, and I used to write it, and then from one stage to another, and I used to mention it as TA minus E1 divided by 1 by HA into A. And he used it, and I am happy that he might have referred some textbook and he might have done it, but I was happy. Okay, because the thing is, if you are able to understand the concept, it's well and good. If you are see, self learning is the most important thing which you have to do, ma, apart from teachers. Yeah, as I mentioned earlier, this e-transfer is a vast thing. I can take conduction for 1 semester, even for 50 hours. Whatever you are studying now in BTech mechanical engineering, it's the basics. What is the basics of conduction, basics of convection, basics of radiation? Okay, these basics we will be covering. And when you go for higher studies, or when you take up a project, okay, then for example, if you do project in solar energy, that is a solar plate collector, okay, then you will be studying about the concepts of heat transfer there. In depth you will be doing it. Yeah, any other thing somebody want to ask, see the question? What is wrong with the question, ma? Anything wrong with the question?
No, no, sir. No, sir. I just wanted to
Yeah.
see if I've taken the values properly, like while
Okay,
sublim.
okay, fine. See, I have given the answers in WhatsApp. Why you didn't see it? Uh, Shrikant says he has solved it, and I have given the answers in WhatsApp. You didn't see it?
No, sir.
In the WhatsApp group, I have given it. Most of you have seen it, right? Students?
Yes, sir.
Yes, sir.
Yes, sir.
See, the purpose of giving answers in WhatsApp, sending messages is to alert you people, and I don't know. Okay, ma. Shall we move on to the next one?
Yes,
Sir,
We
yes,
have
please.
another
Sir,
20 minutes. Yeah, any
sir,
other? Yeah, yes.
sir, that 2A question, sir.
Ah, yeah, tell
Uh,
me, ma.
One second,
2A,
please.
2A, where is 2A? Yeah, this is 2A, ma. Yeah, tell me, ma.
Sir, should we find the okay? Okay, sir. Okay, sir. I just wanted to see the question.
This is 450 ma. This is 70 ma.
Yes, sir. Understood, sir. Okay, sir.
Huh?
Okay,
The
sir.
heat is transferred along the x-axis direction, and there is one person who asked me, sir, whether you have asked me to find the temperature at midpoint between B and D. No, I said no. See, the x-axis direction only we are considering. One-dimensional heat transfer, dou square T by dou x squared. Okay, you are differentiating it twice and you are getting the solution temperature. So y-axis, no need. So if you assume like that, it's wrong. Okay, so I asked the interface temperature between A and BD, and similarly BD and C. Then this is what I asked. Okay, along the x-axis. So at this point, what is the temperature? Is it fine?
Sir?
Yeah.
Sir, will B and D have the same temperature, sir?
No.
Then the interface
B and D won't be. B is having a thermal conductivity of 50, and D is having thermal conductivity of 40. So we are going to calculate the temperature at this interface between this straight line, right? The interface between this BD and C, and this A and BD. And we are proceeding in the x-axis direction. See, the x-axis is the base direction. Am I correct?
Yes, sir. Yes, sir.
We are not proceeding in the y-axis direction. The derivation, whatever derivation we have derived, let me show it to you. See, nothing wrong in asking question, but the thing is you have to study the basics. That's what again and again. See, we are discussing about the x-axis. Where is that composite wall? Yeah. Now you can see here there is no internal heat generation. It is assumed to be steady state, right? If it is steady state, what happens is this becomes 0. And if there is no internal heat generation, Qg divided by K or G by K will be 0. And you are considering the x-axis. So y-axis and z-axis becomes 0. So the equation is d square T by or dou square T by dou x squared equal to 0. Am I fine? Is it fine? Am I correct?
Yes, sir.
Dou square T by dou x squared. So we are considering the one-dimensional thing. First assumption itself, 1D steady state conduction. So steady state means dou T by dou T. There is no variation of temperature with respect to time. So the right hand side becomes 0, one dimensional. So y-axis, z-axis, it's negligible. And G by K, there is no internal heat generation. So Qg by K is also 0. And we assume K. Actually, it is Kx, Ky, Kz. Okay, but we assume the material is isotropic material, which will be having same thermal conductivity along different directions. Is it fine?
Yes, sir.
Correct or not? Yeah. Any other question, ma? Any other question? It's nice at least you people are asking some questions so that I'm able to understand at least whatever I taught, especially the problems. I'm happy, ma. As far as the first 20 students, I don't know about the remaining 50 students, how they did it. As far as the first 25 students, 4 failures were there. Failures means they have got less than 15, 4 or 5. But remaining 20, they have passed. So around 75 to 80% of students, they have passed in the first 25 papers. First 25 papers means it's a random again. Okay, in Code Tantra, the last person's paper will be, register number paper will be the first one. Again, it is shuffled to us. We don't know who is who. We don't know whose answer paper we are correcting in Code Tantra. Shall I move on to the next one? Semi-infinite solid. Shall I start?
Yes, sir.
Okay, fine. Okay, so what about the dimensionless numbers now? Can anyone of you define what is the significance of Wyatt number? What is the significance of Fourier number? Fourier number is dimensionless time, right? Alpha t divided by LC squared. Am I correct? Am I correct or not?
Yes, sir.
Wyatt number is HL by K. Am I correct?
Yes,
Am I
sir.
correct or not? Now
Yes.
tell me, anyone? Charles, are you there? 9 point.
Yes, sir. Biot
Charles.
number is the
Yes,
ratio
Charles.
between.
Who is
Biot
the
number
other
is,
guy? One more guy. 9 pointer is there in my class. I don't know. His name is Vignesh. Vignesh is there. Vignesh. Okay, Charles, you go ahead, Charles.
yes, sir. Biot number is the ratio between the internal conductive resistance to the external convective resistance. So it gives us
surface
whether
conductive
the
resistance or convective resistance, because surface conductive resistance is equal to the convective resistance.
so that
It
gives
depends
us
upon the
like
H
whether
value. Yeah, H
so,
value.
so
It depends upon the H value. Yeah, convective
it
heat
tells us
transfer.
whether the convection or conduction is dominant in the system.
Okay,
But-
very good.
Then Fourier number, it's like the rate of heat diffusion to the amount of
Yes.
heat stored.
Yeah, it gives us the idea about degree of heating or degree of cooling when a solid is exposed to suddenly exposed to a different environment where the temperature may be very high or the temperature may be very low. Okay, the temperature may be very high or the temperature may be very low. See, for example, in food industry, as I mentioned earlier, right? Nowadays we have so many what's that? There are so many, I don't know exactly what to say, tender cuts and FIPOLO and all. What they used to do, they used to store the meat, right? Ice cold storage. Am I correct?
Yes, sir. Yes, sir.
So what happens is when they taken the meat from that ice cold storage, it will be very chill, right? It will be very chill. Okay. Why they are maintaining at minus 10 degrees or minus 15 degrees? Because what happens is so that the meat won't get contaminated, or the meat will be fine. Okay, it will be safe for us to cook the food, right? Cook it as food. Okay, so in food industry, but when they put the meat initially, the meat will be at room temperature, and slowly when they put it again, the meat is exposed to minus 10 degrees or minus 15 degrees, like that. Or keeping an apple inside a refrigerator, right? So apple will be at room temperature. Okay, and then when you keep it inside the refrigerator, slowly what happens is it takes the chillness. Okay, and this thermal diffusivity or the Fourier number, right? The Fourier number gives us an idea about the degree of heating or the degree of cooling, or the thermal diffusivity gives us an idea about how fastly the heat penetrates inside the body, or how fastly it gets chiller when it is exposed to very cold conditions or very hot conditions, right? And this is also very much useful in rocket science as well as in cryogenics. Okay, these ideas, the basic concepts of heat transfer, it's very important. Okay, because what happens is we know that, okay, even in aircraft, right? So the density of the air, when it reaches a certain height, whether the density of air will be the same as the air which we have in the atmospheric surface at the ground level, whether the density is same.
No, sir.
Why? Whether it is less or whether it will be higher. Hey, engineers, pa.
As we go higher, the density will get lower, sir.
Yes, very good. The density will get lower. That's why the propeller fans were there in the aircrafts, right? Nowadays we have turbines only, gas turbines only. No internal combustion engines nowadays. Turbine only. In case of turbines, you will be having propellers, right? Am I correct or not? Fans, propeller
Yes, sir.
fans. What is the purpose of fan? The general purpose of fan is to draw in air, right? So high dense air is needed. So when the propeller runs at a faster rate, it draws in more air so that it increases the density, and slightly higher density air will be sent into the combustion chamber, where you will be having mixing of air and then combustion, and then the exhaust gases will be blowing out through the exhaust at a faster rate. Turbine, and you will be having combustion chamber, you will be a propeller, combustion chamber, and you will be having the turbine exit. And the turbine exit, what happens is you will be having the exhaust gases which will be gushing out at a faster rate. See, this is very, very important. That's what I said. The practical application. You may get a problem, right? In CAT 2 or in the FAT exam. Okay. Especially in natural convection as well as in forced convection. The vehicle, the aeroplane running at a certain height, at a certain speed of say 70 nauticals, or 70 kilometers per hour, or 120 kilometers per hour, like that. The problem may be given. Okay, and so surrounding atmospheric air will be at say 5 degrees C, or 3 degrees C, like that. Okay, so please understand that these things are very, very important. So as I mentioned earlier, the Fourier number, it gives us an idea about, actually it's a ratio, right? Fourier number, again, you have the definition here. It's a dimensionless time, and it is the ratio of heat conducted to the rate of heat stored at that time, or in other words, it gives us an idea about how faster the heat is that is heat the body gets heated or the body gets cooled. Okay, so and these things you are supposed to understand. And one more thing, we have already discussed about infinite solid and lumped system. And when it comes to infinite solid, to get the solution, what we use is we use the Hazel's charts. The Hazel's charts will give us an idea about so you will be having the temperature distribution on the y-axis, and on the x-axis you will be having the tau value, time value, and with the help of 1 by Biot number, you will be finding out the temperature. Okay, central line temperature of the body, or temperature at any instant. Okay, so mid-plane temperature also you will be finding out, or you will be finding out temperature of a body at certain points. Okay, so whether it is again if it is solid, flat plate, or it is a cylinder, or it is a sphere. Okay, depending upon it. Okay, you have to refer the chart, and you have to do it. Okay, and most of the students, they didn't attend the evening class which I took, and I have solved all these 3 problems, especially for CAT 2. We may ask, please understand, we may ask infinite solid also. Hope you understand, and please don't say, sir, you have not mentioned this particular portion was included in CAT 1, so I didn't study it. Please don't say. Please don't say it. Okay, so for CAT 2, you may get question from infinite solid. So in case of infinite solid, the Biot number will be greater than 0.1. So first you have to check the Biot number again. Okay, so that's the significance of Biot number. One of the significance of Biot number. So whether we have to assume the heat transfer as lumped system, or whether we have to assume it as infinite solid. Now, what about the semi-infinite solid? What about the semi-infinite solid? Now, infinite solid, we know that a solid extends infinitely itself in all directions of space is termed as an infinite solid. And semi-infinite solid, usually it is nothing but if an infinite solid is split in the middle by a plane, each of is known as semi-infinite solid. And in case of semi-infinite body, at any instant of time, there is always a point within the body where the effect of heating or cooling at one of its boundaries is not at all felt. It's not at all felt. See, this is very especially the some of the students, they have written sprinkler of water on a highway. Yes, it's very good. Okay, even in the slide, I think, oh, I didn't give the problem. Okay, okay, fine. Okay, so what happens is see, uh, assume that you have a highway, and during summer, the highway road surface will be extremely hot, right? It will be extremely hot, and we can see that some of the tar, it will start slightly melting, right? And what happens is, all of a sudden, when you get rainfall, right? or cloud burst, due to cloud burst, when you get all of a sudden rainfall, what happens is the rainfall will not be uniform throughout the surface, right? It will not be uniform throughout the road, right? So what happens is, that's what, at some points there will be the chilling effect will be felt, and at some points there won't be any chilling effect. Or so rain, that is a rain splashing or water splashing on a national highway or a very long highway on a hot summer day can be taken as a semi-infinite solid, or we can assume, we can proceed the problem. Okay, or in other words, the boundary conditions where it will be x comma 0 equal to ti, where the surface temperature is equal to the initial temperature, and at x equal to 0 and after time t, it becomes ts, and at x equal to infinity and at time t, it is again, it is equal to the initial temperature. Okay, so x comma 0, infinity comma t, it is ti, initial temperature. So what it suggests as is, even after some time t, some of the points, in the subplane will be at the initial temperature, or the temperature change, it is not felt at all. It is not felt at all. And if you want to that is if you want to have examples also, that's what, if you can take a steel plate, and all of a sudden it is exposed to one side, a hot fluid, the other side, if it is exposed to air. Okay, and depending upon the thickness of the material, okay, what happens is, the other end, there won't be any temperature change even if the hot fluid flows on one side. Okay, so that can also be treated as a semi-infinite solid, or technically speaking, when we talk about semi-infinite solid, it is a solid which extends itself infinitely in all directions of space, except, or in other words, all infinite is, that is, I'm sorry, a solid which extends infinitely in all directions of space is termed as infinite solid. And if an infinite solid is split into two, then it is said to be semi-infinite solid. Okay, then it is said to be semi-infinite solid. And what happens is, there will be some points in the solid where the effect of heating and the effect of cooling will not be felt, or it will not be felt at all. Okay, so this is said to be semi-infinite solid. And as far as semi-infinite solid is concerned, okay, so at x comma 0, the temperature is initial temperature, and 0 comma t, after some time t, it is ts. And there are three cases. The first case is constant surface temperature, and the second case is constant surface heat flux, and the third case is surface convection. Now for all these things, we will be using the Gaussian error function of z value, and error function of z value. For example, for the first case, tx comma t minus ts divided by ta minus ts, which is equal to error function of x divided by 2 into root of alpha t, where small t is nothing but the time, and ts is nothing but the surface temperature, and tx comma t is nothing but the temperature at which you want to point, that may be a point from the surface at a certain depth, okay, after some time t. And for example, if you have a solid, if you have a thickness of solid, say 5 centimeter or 10 centimeter, what is the temperature at a depth of 2 centimeter? So then that particular thing is said to be x. Okay, x equal to 2 centimeter or 3 centimeter after some time t, and ts is nothing but the surface temperature, and ta is nothing but the initial temperature. Okay, which is equal to error function of x divided by 2 into square root of alpha t, where alpha is nothing but the thermal diffusivity of the solid, and t is nothing but the time taken, and x is nothing but the depth or the distance. Okay, now this is also I am supposed to say to you. Students, all of you are able to see this?
Yes, sir.
Yes,
Yes,
sir.
sir.
So now you can see here Tx minus T naught divided by Ti minus T naught, which is equal to error function of x divided by 2 into square root of alpha tau. Tx is nothing but temperature at a distance x from surface after some time tau, and T naught is nothing but surface temperature, and Ta is nothing but the initial temperature. So now error function of Z. Okay, so now you have two things here. Error function of Z. Suppose if you have this value x divided by 2 root of alpha t, if for example if it comes as 0.12, error function of 0.12. So error function of 0.12. For example, 0.11 is here. So not 0.1 here. Yeah, error function of 0.12. Error function of Z is 0.12. For example, if this error function of this x value, x by 2 root of alpha t, if it comes as 0.12, so error function of 0.12 is equal to this value, the right hand side value 0.12. So Z is equal to 0.11. So you should not write 0.12. So Z is 0.11, and after getting Z, then you have to substitute the Z value, and you are supposed to find out what is X. Okay, so that is very, very important when we solve this problem. Anyway, I will be solving one or two problems. Okay, when I solve that, you will be able to understand. Okay, why I'm saying like that. Okay, how to get X value and how to find out error function of X. Is it fine?
Yes, sir.
Yes.
Yeah. Any questions you want to ask, you can ask, or otherwise I will stop the recording and we will wind up for the day.